Download this code from codegive.com, link in the description below. OK, let's dive deep into second and third normal forms, 2NF and 3NF, with SQL examples. This tutorial will explain the concepts, demonstrate the problems they solve, and provide practical SQL examples to illustrate how to achieve these normal forms. Introduction to normalization. Database normalization is a process of organizing data in a database to minimize redundancy and improve data integrity. It involves dividing databases into two or more tables and defining relationships between the tables. The goal is to isolate data so that amendments of an attribute can be made in one place only. Normalization reduces data redundancy and thereby improves data integrity. Normalization typically involves dividing a database into two or more tables and defining relationships between the tables. The objective is to isolate data so that modifications of an attribute can be made in just one table. Why is normalization important? Reduced data redundancy. Eliminates duplicate data, saving storage space and improving efficiency. Improved data integrity. Ensures that data dependencies are properly enforced, preventing inconsistencies. Easier data maintenance. Makes it easier to update, insert, and delete data without introducing errors. Better query performance. Often leads to more efficient queries as data is organized logically. Consistent data. Data appears consistently across the database. Normal forms. Brief overview. Normalization is achieved by following a series of guidelines called normal forms. We'll focus on 2NF and 3NF, but here's a quick list. 1NF, first normal form. Eliminate repeating groups. 2NF, second normal form. Eliminate redundant data that depends on only part of the primary key. 3NF, third normal form. Eliminate redundant data that depends on other non-key attributes. BCNF, voice code normal form. A stricter version of 3NF. Addresses specific edge cases. 4NF, fourth normal form. Deals with multi-valued dependencies. 5NF, fifth normal form. Deals with join dependencies. 2NF, second normal form. Definition. A table is in 2NF if it meets the following conditions. 1. It is in 1NF, first normal form. 2. All non-key attributes are fully functionally dependent on the entire primary key. In other words, no non-key attribute depends on only part of the primary key. What is functional dependency? A functional dependency exists when the value of one attribute, or set of attributes, uniquely determines the value of another attribute. We write this as A-B, A functionally determines B. This means if we know the value of A, we can find the value of B. Example, breaking 2NF. Let's consider a table called order details. Order ID, product name, quantity, price, supplier ID, supplier name, supplier address. Dash 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 101A 123 widget 210.00 S10 Acme Corp 123 Main Street 101B 456 Gadget 125.00 S20 Beta Inc 456 Oak Avenue 102A 123 widget 310.00 S10 Acme Corp 123 Main Street 103C 789 Thingy 55.00 S30 Gamma Ltd 789 Pine Lane. Assumptions Order ID and product ID together uniquely identify each row, they form the composite primary key. Product ID determines product name. Asterisk supplier ID determines supplier name and supplier address. Problems asterisk. 1. Redundancy asterisk product name, supplier name, and supplier address are repeated for each order item. 2. Update anomaly asterisk if we change the supplier address for S10, we have to update it in multiple rows in the order details table. If we miss one, the data becomes inconsistent. 3. Insertion anomaly asterisk we cannot add a new supplier to the database without having an actual order using that supplier. 4. Deletion anomaly asterisk if we delete the last order from a specific supplier, we might inadvertently lose the supplier's information entirely. The problem is partial dependency asterisk. Asterisk product name depends only on product ID, part of the primary key. Asterisk supplier name and supplier address depends only on supplier ID, not part of the primary key but relates to a part of the primary key. Solution: decompose into two NF tables. We'll split the order details table into 3 tables. 1. Orders, stores the main order information. 2. Order items, stores the association between orders and products and the related quantity. 3. Products, stores product information. 4. Suppliers, stores supplier information. SQL code for the new tables asterisk. Populating the tables, example data. Explanation asterisk. Asterisk products table now stores product information, with product ID as the primary key. Product name is fully functionally dependent on product ID. Asterisk suppliers table now stores supplier information, with supplier ID as the primary key. Supplier name and supplier address are fully functionally dependent on supplier ID. Asterisk order items table stores the relationships between orders and products, using order ID and product ID as a composite primary key. It also stores the quantity and price of the product for that particular order. Benefits asterisk. Asterisk no redundancy asterisk product and supplier information is stored only once. Asterisk improved integrity asterisk changing a product name or supplier address only requires updating a single row in the products or suppliers table, respectively. Asterisk no insertion / deletion anomalies asterisk we can add or remove suppliers independently of orders. 3. 3NF, third normal form. Definition asterisk. A table is in 3NF if it meets the following conditions. 1. It is in 2NF. 2. No non-key attribute is transitively dependent on the primary key. What is transitive dependency? Transitive dependency means that a non-key attribute depends on another non-key attribute. If we have attributes A, B, and C in a table, and *A-B, A determines B. *B-C, B determines C. Then, A-C, A transitively determines C. Example, breaking 3NF. Consider the following employees table. Employee ID, employee name, department ID, department name, department location. Dash 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 dash. 1. John Doe 101 Sales New York. 2. Jane Smith 102 Marketing London. 3. Peter Jones 101 Sales New York. Assumptions asterisk. Asterisk employee ID is the primary key. Asterisk department ID determines department name and department location. The problem is transitive dependency asterisk. Asterisk employee ID dash department ID. Asterisk department ID dash department name and department location. Therefore, employee ID transitively determines department name and department location. Problems asterisk. 1. Redundancy asterisk department name and department location are repeated for each employee in the same department. To update anomaly asterisk if the department location for the sales department changes, you need to update multiple rows in the employees table. 3. Insertion anomaly asterisk you can't add a new department without having at least one employee assigned to it. 4. Deletion anomaly asterisk if the last employee in a department leaves, you might lose the department's information. Solution: decompose into 3 NF tables. We'll split the employees table into 2 tables. 1. Employees, stores employee information and the department they belong to. 2. Departments, stores department information. SQL code for the new tables asterisk. Populating the tables, example data. Explanation asterisk. Asterisk the departments table stores department related information, with department ID as the primary key. Department name and department location are fully functionally dependent on department ID. Asterisk the employees table stores employee information and references the departments table using the department ID foreign key. Benefits asterisk. Asterisk no redundancy asterisk department information is stored only once. Asterisk improved integrity asterisk changing the department location only requires updating a single row in the departments table. Asterisk no insertion/deletion anomalies asterisk we can add or remove departments independently of employees. 4. Summary and key takeaways. Asterisk 1 NF asterisk eliminate repeating groups. Ensure each column contains atomic values, indivisible. Asterisk 2 NF asterisk be in 1 NF and eliminate redundant data that depends on only part of the primary key, for tables with composite primary keys. Address partial dependencies. Asterisk 3 NF asterisk be in 2 NF and eliminate redundant data that depends on other non-key attributes. Address transitive dependencies. General approach to normalization asterisk. 1. Identify the data asterisk clearly define the entities and attributes you need to store. 2. Establish primary keys asterisk choose appropriate primary keys for each table. These keys must uniquely identify each row. 3. Identify functional dependencies asterisk determine which attributes depend on which other attributes. 4. Apply normal forms asterisk start with 1 NF, then move to 2 NF, and then to 3 NF, splitting tables and creating relationships as needed. Important considerations asterisk. Asterisk over normalization asterisk while normalization is good, too much normalization can sometimes lead to overly complex queries and performance issues due to excessive joins. Asterisk denormalization asterisk in some cases, you might intentionally denormalize parts of your database, add redundancy, to improve read performance. This should be done with caution and careful consideration. Asterisk start early asterisk it's best to design your database with normalization in mind from the beginning. Retrofitting normalization to an existing database can be a significant undertaking. SQL tips for normalization asterisk. Asterisk foreign keys asterisk use foreign keys to enforce relationships between tables. This helps maintain data integrity. Asterisk indexes asterisk create indexes on frequently queried columns, especially foreign keys, to improve query performance. Asterisk constraints asterisk use constraints, example not null, unique, check, to enforce data quality. Practice exercises asterisk. 1. Order processing database asterisk imagine you have a table containing order processing data with fields like order ID, customer name, customer address, product ID, product name, quantity, price. Identify if this table is in 1 NF, 2 NF, or 3 NF. If not, normalize it to 3 NF by creating the necessary tables and relationships. Provide SQL code for the tables and insert statements for example data. 2. Library database * consider a books table with attributes like book ID, title, author ID, author name, author nationality, publisher ID, publisher name. Analyze the table for normal form violations and normalize it to 3NF with corresponding SQL code. These exercises will help you solidify your understanding of 2NF and 3NF and practice applying the principles to real-world database design scenarios. Remember to think about the dependencies between attributes and how to best represent the data in a relational database. Good luck.